Hello, I'm Michael Schachter, Senior Product Marketing Manager at Allot, and I'm here today at the Allot Mobile Virtual Conference. We'll be talking in the next session with Itai Weissman, the Allot Vice President of Markets and New Technologies. And Itai will be explaining to us something about the challenges and opportunities that 5G presents to a company like Allot. Itai, over to you.
Hello everybody, nice to meet you all. So this presentation will be threefold. First we're going to go over some of the key objectives of the 5G networks, which I assume you all know, so we'll skip through it. Then on the key challenges that will have to be accommodated for in order to achieve these key goals. And eventually, I will share with you what Allot technologies can do in order to assist you achieving your business goals with the 5G networks. So let's start with a brief introduction. I'm sure you're all familiar with it, of the business objectives. Well, there are two main business objectives, as always, increase revenue and decrease cost. But with 5G networks, there are specific items in which we see a lot of operators are actually aiming at when they are talking about increasing revenues. So first, it's the concept of an SLA-driven business model, where the network can deliver an SLA that is specific to the application. So if it's a video, it will be a no-stall video session at high definition. And if it's gaming, it will be low latency for gaming. The second is to leverage the ability of software as a service vendors to come and utilize the network and actually bundle their offering with the network. And this is done by creating a value for the specific software as a service. So for example, if Netflix wants to have better quality, better streaming quality when they are going to their consumers, the network itself provides them with the ability to do so by placing some of the Netflix component in the network. Same goes for manufacturing flow automation, where you need to have very low latency. The network allows you to deploy within the network. So the network itself is part of the service cloud. And the third is IoT focus. We all know IoT is considered to be one of the growing areas of the next few years. And it is expected that IoT will create a lot of revenue, and IoT does have different requirements for different types of IoT, and the network is built to entertain for it. On the cost reduction part, the whole environment goes into cloud native. You all understand what cloud native means. I will not repeat it, but the idea here is to be able to deploy services rapidly and to allow the service itself to grow or scale down very fast and automatic. Another concept that is coming to view more and more in the last year or so, it's the backhaul cost reduction, where there is an understanding that hauling traffic to the central data office costs a lot of money, and as soon as you can send the traffic to the internet as closer to the cell as you can, that will reduce costs. So from this came the concept of network edge computing, and then also mobile edge computing that is allowing application deployment at the edge. And the last thing that we see more and more is leveraging on content partners in order to reduce costs. So for example, at the mobile edge, if a network operator deploys a Netflix cache, he's actually having the Netflix provide the better service instead of hauling all of the traffic all the way to Netflix. So all of these mechanisms are coming basically to support better service and to allow for more creative use cases. And in the use case scenario of the 5G, I'm sure you're also very familiar with that. We see three main use cases. One is for Massive machine type communication, that's a lot of IoTs on a very small segment of land. This has very specific requirement like very low cost and very high density. And then we have the enhanced mobile broadband. This is basically bigger, better, faster, more of what you have today in the 4G. And then on the other end, we also have the ultra reliable and low latency devices. These are the type of IoT devices like car-to-car communication, machine floor automation that require very, very fast response time. Now, every one of these capabilities that I've discussed, any one of the pillars of this triangle, requires different capabilities from the network. And the network is built in order to provide these capabilities and to mix and match between them and cater for every service independently by creating the exact environment that it needs. And it is mapped to quite a lot of use cases. I'm sure I don't need to talk about the technologies, but what we see as two main technologies allowing for this. One is the network slicing that allows you basically to create a network of a virtual network of your own from the radio all the way to the core and the services with specific SLA parameters. The second is the edge computing, which is deployment very close to the radio. This will have tens, sometimes even hundreds of mobile edge computing in a relatively small area, like 50 square kilometers, or a big city. And it is, this is where the CSP will provide his edge cloud for applications that require low latency. And this is where the local breakout will be. And it will save cost on expensive fibers to the data center. Another thing that we have seen is that the architecture, the SBA service-based architecture of the 3GPP changed. There used to be 3 different devices that used to manage user plane traffic, the S gateway, the P gateway, and the TDF. All of these are consolidated now into a single user plane function. It's called a UPF that is aimed to cater the capability of all 3 in conjunction. And I would like to stop here and saying, having looked at all of these capabilities, one might ask, okay, so basically all of the capabilities are given within the network. Why do we need anything else in order to create revenues and to create value? And this is where the main challenges of bringing this network to fruition come to pass. So the first challenge that we've seen through talking to you guys, one is the service protection. User plane protection became much more complicated. First, with the introduction of mobile edge computing, you are adding a lot of mini clouds. They have a relatively low capacity and they have internet access and they have applications that are not operated applications running on them. This means that there are new intrusion points into the network that you are not currently looking at. And it's also very easy to attack. Once you have an application running in a mobile edge, it is very easy to create a DDoS aimed at this application and reach very fast traffic loads that are beyond whatever the application can manage. So if you have a 20 gigabit mobile edge compute, it's very easy to take it down. So this is in terms of attacking the mobile edge, but also if you are talking about attacks coming from internal hosts of the system, you are significantly increasing the amount of internal hosts by adding IoT devices. Many of these IoTs have absolutely no protection or very low protection capabilities. They are extremely vulnerable and it is very difficult to update them because they are aimed to be low cost. So these massive amounts of IoTs connected to the network, they can create massive amounts of attacks, and such a single IoT can go up to 1 gigabit per second of attack. It's very easy to create IoT bots this way. Okay, so basically what we can see is that the introduction of mobile edge compute and a vast amount of IoT devices create new threats that needs to be managed. On top of it, the old attacks, the old DDoS attacks coming from outside the network are now much more diverged. Instead of attacking the network through 10 locations, they are most likely to attack it from the entry points to the network is not 10, it's in the hundreds. So the old approach of scrubbing centers might not be good enough because it will take too much time to cover all of these attacks. On the QoE front, slicing is considered today as the answer for QoE. If an application needs a resource, it will ask for it, and the resource shall be given. But slices are not really meant to manage congestion. Slices are meant to assure SLA when there is enough resources. But what happens if there isn't enough resources? I mean, no network has enough resources. So one slice wants a certain amount of resource, the other slice wants it too. There's not enough for all of them to go around. The second is slices are not aimed to cater for thousands of over-the-top applications. These applications are very unlikely to ask for resource or to be integrated into the network, and in any case the mechanism is not meant to manage thousands of slices within a single network. Every slice takes its own resources, and operating a network in a way that everything is pre-guaranteed is a waste of a lot of resources, and it will become unmanageable. So congestion will occur even with slicing, and slicing is a very limited way of managing it, and mostly towards the provision applications by the CSP. And obviously, if the slice is congested, the SLA for the slice is not met, and that means you need to have a way to measure the application quality of experience within the slice to make sure that the slice is indeed congested or not. Another thing that we are seeing is that in order to create revenue, there is a need for a new business model, and there is a need to migrate to a QoE-based plans. Why do we see it? Well, the first thing we see is that common data packages in the Western world today is around 100 gigabytes per month. Now, the average user consumption, and I'm giving you an example here from Japan, it's 20 gigabytes per month. So you're actually selling 5 times more than the average consumer actually needs. So it means that in the eyes of the consumer, the value perception of volume-based charging is diminishing, and you need something else to create revenue from, otherwise we will be stuck with the 4G revenue model. So in some European customers, we start seeing a migration towards bandwidth-based plans. That's a good migration, but even with bandwidth-based plan, you are still lacking the perception of value. I mean, from a consumer standpoint, what is the difference for me between 300 megabits or 1 gigabit? Can I see or can I not see? YouTube high definition with that. So the next step of evolution is creating charging plans that present value to the customer, and this is done by talking about what they get, what application quality of experience they get. This is not part of the inherent 5G mechanisms today. And the last challenge that we see is the transport cost. So yes, 5G dramatically reduces transport cost on a per bit basis compared to 4G. But there are much more bits in 5G, and furthermore, there are much more locations that needs to be managed from which these bits are coming from. And this means that there's more leased transport. If you are deploying mobile edge, many of you will actually not pave the fiber, but will lease the fiber. This means that there are costs there, and you want them to be aligned with your business model and with what you're charging. So the idea is to be able to analyze the traffic and to decide what traffic goes through what route according to the traffic priority and the traffic value. That will be that type of mechanism will reduce the cost and will allow you more flexibility when you're creating your business plan. Okay, so where Allot is playing in this game, and what can we do for you? So in our view, a UPF that combines DPI capabilities that can do actual QoE analysis and enforcement is key in order to achieve any one of the business goals that we've just discussed. The content-aware marketing, creating new value-based service plans, the network service protection, the OPEX reduction, and the QoE-centric network operation and congestion management. And some of the use cases that, some of the more common use cases that we see are presented here. First one is QoE visibility and assurance within a slice. If you have a slice with thousands of OTT applications, you can make sure which of them is getting the correct service and at what cost. QoE-aware mobile edge computing and backhaul cost reduction. So as you can see that there are many links connecting the mobile edge either directly to the internet or to the central office. Our devices can understand what applications needs to be delivered to the central office and what can go directly to the internet, controlling the cost of the application. And this goes through an OTT application, not just for applications that you provision. Tiered service plans. Again, the ability to create service plans that create value to the end users. For example, this is a low-end plan, only YouTube SD. This is a high-end plan, we guarantee video, YouTube HD. And network protection will come into it, but we have mechanisms to protect the entire network from DDoS as well as protecting the mobile edge from other sorts of penetration. Okay, so one of the main value propositions of a UPF with DPI capabilities as ours that is QoE aware is the ability to assure the experience while using OTT applications, network or Hulu or Prime Video or whatever gaming application you choose. They are not necessarily a partner of the CSP, but still you can guarantee the service and you can charge for it. So the first thing you need is you need to have the granular application detection capabilities. The ability to discern YouTube SD, YouTube HD, Netflix Ultra 4K, gaming, you need to understand whether it's a chat, whether it's a gaming command, etc. Okay? You need to have the ability to provide unique QoE analysis per application. Not all applications have the same metrics according to which you need to measure the QoE. For example, video streaming, you need to count stalls and delays, and gaming, you need to count messages and completion. All of these capabilities needs to be there in order to assure accurate QoE measurement. And at the end of the day, you need to close the loop and take the action and enforce the QoE. So at any given time, you will have the correct QoE, the QoE that you promised on a per application basis. Or for example, during peak hours, you promised YouTube HD to some of your customers, so you will provide him with the YouTube HD at the expense of other non-QoE affecting applications. And this is key. Guaranteeing QoE is key in order to allow for a really service-based architecture and to leverage on OTT applications. So as we mentioned before, protecting the network assets, in particular the mobile edge and the core from DDoS attacks and from bot infestation, is a major challenge that today is not covered. And this is where our solution comes into play. We have the ability to deploy at either the mobile edge or the central office or any one of the, or any combination of the above, to protect against inbound DDoS attacks, both for directly to the mobile edge as well as to the central office. Because the solution is inline, it responds immediately and immediately cleans the attack. It is also capable of protecting from outbound in DDoS attacks that are coming from the host of the network. Identify hosts that are attacking, isolate them, and control the attack. And on top of all of these capabilities, we also have the ability to identify bots and clean and prevent the infestation of bots, protecting both the IoT attacks as well as services running in the network, either at the mobile edge or at the central office. And this is all part of the Allot UPF, so you get it as part of the core component. Okay, thank you very much, guys. I think we've covered the very high-level view of 5G challenges and our responses to these challenges. And I hope you find this educational.
Thank you very much, Itai. It's certainly a lot of material to incorporate, to digest. If you could just repeat a little bit about why it is that if it's such a service-oriented, service-designed architecture, and it's meant to, as you said, enable CSPs to guarantee SLAs and so on, why is it that a third-party solution is still needed to guarantee and assure QoE?
Yeah. So first, it's meant to guarantee SLA to provisioned applications. Not every application is provisioned. There are a lot of OTT applications. Mm-hmm. Granted, some of the mechanism can also be used for OTT applications, but then you need a way to somehow identify the OTT application. And its identification is more than just saying this is YouTube, but exactly what type of film it is, what resolution, what is the quality of the viewing experience. Mm-hmm. These are things that the network itself does not provide. So if you want to do that, you need to have a mechanism that actually measures the real QoE and the specific QoE for every application, and knows how to enforce rules that can be done by services the network provides, but you have to tell the network to enforce these rules in order to assure this QoE.
Okay, well, thank you, Itai, and thank you all for joining us. We'll be happy to host you at other parts of the conference. You can find your way about the virtual demo space, and please feel free to use one of the forms that will shortly appear in order to sign up for a direct meeting with one of our executives. Thank you, and enjoy the rest of the conference.